Today's lesson is 2.3, Solving Systems with 3 Variables. For the first example, we're going to go ahead and go over the elimination method one more time. Remember that we want to label them as equation 1 and equation 2. And what we're looking for is the same coefficient in front of the variable. So let's take a look at our x's first. I see a 2 and I see a 5. That is not the same variable. That is not the same coefficient. Let's go ahead and look at our y variable. I see a 6 and I see a 3. Once again, not the same coefficient. So what I have to do is use the method where I multiply both equation 1 and equation 2 by some number. Now, I can do this for both of them or just one. So I could choose to make the x's have the same variable. To do so, I would multiply equation 1 by 5, the coefficient I see in equation 2, and I would multiply equation 2 by 2, the coefficient I see in equation 1. So it would look something like this. Now you might be thinking, well, wait, I want to do the y's. If I do the y's, if I multiply 3 times 2, I get 6, which means I only have to multiply equation 2, not both. Either method is perfectly fine. It doesn't matter which one you do. It's going to get you your solution. So let's go ahead and multiply just equation 2 by 2. And, well, hold on a second. I'm going to keep it in this color. Because the 2's not coming from equation 1, it's simply coming from 3 times 2 equals 6. All right, so this equation is going to then become 10x minus 6y equals, I don't know what 88 times 2 is. I forgot my calculator. Let me see, let me do it over here. Well, that's 16, carry the 1, 176. There we go. Let's erase that. There we go. Okay, this one I'm simply going to copy. I'm not going to change it at all. I'm simply going to copy it. Now that I see that my y's are exactly the same, they have the same coefficient 6, I can go ahead and I can decide if I should add them together or subtract them. Remember, you need to look at the signs to decide that. They are different signs. Remember, the rule is same signs subtract, so different signs. We're going to go ahead and add together. Let me grab a different color, and I'm going to go ahead and add these two together. Remember, I'm adding the x's, I'm adding the y's, and I'm adding the constants. I'm adding each group. So 2 plus 10 is 12. 6 plus negative 6 would cancel out, which is exactly what I wanted to do, eliminate one of the variables. And let's see, negative 8 plus 176 would be, I want to say 168. I'm going to flip it around over here, right? Yep, 168. There we go. Okay, now I can go ahead and I can solve for my variable x. Remember, there's multiplication hiding in between, so we're simply going to go ahead and divide by 12. And once again, I forgot my calculator, so let me go ahead and do this the longhand over here. Let's see, 12 goes into 16 one time, which leaves me 4. Bring down the 8, goes in there 4 times, 48, which is 0. So my answer is going to be x equals 14. All right, now that I have x, remember I'm going to go back and I'm going to substitute it in to either equation 1 or equation 2 to solve for y. It's my choice. So the only thing that I would maybe take a look at is the positive y versus the negative y. But once again, it really doesn't matter. It really doesn't matter. I'm going to go ahead and choose equation 1 because I think I can do that one a little bit easier than I could equation 2. All right, but instead of x, I am of course going to put the 14 that we just got. There we go. I can go ahead and solve this equation for the variable y. I'm first going to do 2 times 14. That would be 48. -8, there we go. I'm going to go ahead and get rid of my addition by doing subtraction. Okay, now let's see. I can do this. They're both negative, right? So we're going to add them together. 8 and 8 is 16. Carry the 1, negative 56. Remember, the last step should always be to get rid of that multiplication. It should almost always be that. Very few times your last step is to get rid of division. I think that's negative 7. Okay, so just a quick reminder. And then, of course, if we were asked to write it as an ordered pair, of course, it would be 14 comma negative 7. That's just if we were asked to write it as an ordered pair. All right, let's go ahead and take that same idea now, and let's solve this system by using elimination. So once again, notice it is asking me to use elimination. I'm going to go ahead and label the equations 1, 2, and 3. All right, what I'm going to start looking for is I'm going to start looking for two equations with the same coefficients. So let's take a look at the x's. Look at this, you guys. Every single x has a 2 in front of it. What that means is I can very easily start to eliminate the x values, which will help me to solve for y. Not to eliminate, it will help me to solve for y. So the first thing I'm going to do is I'm going to grab equation 1 and I'm going to grab equation 2. Let me grab that color. And I'm going to eliminate the x value. I'm going to eliminate the x value. So 2x, and then I'll change back my color. And then this one was negative 2x. You might be noticing something else that's pretty cool about these two. I just saw it. I hope you did too. But remember, we're eliminating these guys right here. So I'm looking at their signs. The sign of the 2 in equation 1 is positive, and the sign of the 2 in equation 2 is negative. They are different signs, so we're going to go ahead and add them together. 2 plus negative 2 will give me 0. I'm going to go ahead and add, add. I'm going to go ahead and change that color so that you can see that a little bit better. Add, add, add. All right, here we go. 5 plus 5 is 10. Y tags along. 6 plus negative 3 is positive 3. Z tags along. And 1 plus negative 5 is negative 4. All right, if you were thinking that maybe we would be able to eliminate the 5y's as well, good eye. It didn't happen this time because of the addition, but we are going to go back and possibly use that later. Now, this equation is a new equation, and we're going to call it equation number 4. Ooh, okay. Now I'm going to go back and I'm going to use equation 2. Equation 2, once again, remember I'm really focusing on those x's. I'm really focusing on eliminating the x's. That is my goal. And then I'm going to get equation number 3. I'm going to leave myself a big space because as you can see, equation number 3 does not contain, it does not contain a z. So if I wanted to, I could go ahead and do this 0z. I'm going to put a slash through it so I don't think it says Oz. There we go. All right, let's take a look at our 2's. Our 2 in equation 1 is, or equation 2 is negative. Our 2 in equation 3 is negative. They are the same sign, so we are going to subtract. Negative 2 minus negative 2 is going to give me 0. Now remember, there we go. We're gonna, subtract, subtract, subtract. Okay, 5 minus negative 3y gives me 8y. Negative 3 minus nothing. Negative 3 minus nothing gives me negative 3z. And negative 5 minus negative 9 gives me, of course, negative 14. This will be equation number 5. All right, you're probably thinking at this point, Miss, this is crazy. This is way, way, way too much. But take a look at equations number 4 and 5. They both contain the variables y and z. I should be able to eliminate from them. So I'm going to take equation number 4 and equation number 5. And I'm going to see if I can eliminate something. So let's go ahead and take a look. I'm paying close attention to the coefficients, the numbers in front of my variables, the letters y and z. There we go. So what I kind of see here is that the y's contain different numbers, 10 for equation 4 and 8 for equation 5. I would have to multiply to eliminate there. But let's take a look at the variable z. Notice I have 3 in front of the z in equation number 4 and 3 in front of the z in equation number 5. I can eliminate that. One of them is equation 4 is positive 3, equation 5 is negative 3. They're different signs. So I'm going to go ahead and I'm going to add them together. Let me go ahead and change the colors so that you guys can see what it is that I am eliminating. So I am eliminating my positive 3 and my negative. There we go. That's what I'm going to eliminate, okay? So 3 plus negative 3 gives me 0. What I do to those, I have to do to these guys. So I'm going to add 10 plus 8, and I'm going to add negative 4 plus negative 14. Well, 10 plus 8 is 18, and of course, y tags along. The z's have disappeared. Negative 4 plus negative 14 is negative 18. To solve for the variable y, I think I should change that to orange. There we go. Remember, there's multiplication hiding there. So I'm simply going to divide by positive 18. Negative 18 divided by positive 18 is negative 1. I have my first answer. I have my first answer. Now what I'm going to do is I'm going to go back and I'm going to plug it in. Now I'm going to plug it in either to equation 4 or to equation 5. Why? Because that's going to give me the value of z. Notice that the only other variable in equation 4 and 5 is z. It's completely my choice. Completely my choice. So I'm going to go ahead and choose, I think this one. I think maybe that one. Yeah, let's do that one. It doesn't matter. Or, yeah, that's fine. I was going to change it to equation number 5, but that's okay. And the only reason for that is because I had the green pen. All right, so 10, but I'm going to change the y to -1 plus 3z equals -4. Well, 10 times -1 is, of course, -10. Okay, let's see. We're solving for z. We're solving for z. Let me remind myself that we're solving for z. Okay, so let's get rid of that addition, but be careful. We're adding a negative. So it's really the negative that we want to get rid of. So we're going to go ahead and add 10 to the other side. -4 plus 10, -4 plus 10 would give me +6. Remember, whenever you have a number in front of a variable like 3z, there's multiplication hiding there, which simply means we must divide to solve. Here is my second answer, z equals 2. There we go. All right, now all I have to do is find x. I'm going to go back to the original 3 equations to help me find x. Because x is in each of the original 3 equations, I can put it into whichever one I want. You might be thinking, this one right here. Very good choice. That's because it only contains the variable y. It does not contain the z. But you could not go wrong by plugging it back into equation 1 or 2 since you know the values of y and z already. So I'm going to choose this one because it's just going to give me a little less work. It's going to give me a little less work. So I'm going to go to equation number 3, and I'm going to plug in my y value. What was my y value? -1. All right, so that would give me -2x plus 3. Look, it's -3 times -1, which is a -3. The double negatives are going to become a positive, equals 9. Remember, I'm solving for the variable x, so let me pull my purple in. Not that it matters, but there we go. I'm going to have to move over here because I'm running out of space. This happens quite a bit when you are solving a 3 systems and 3 unknowns. You tend to run out of space. So I took my answer here and I moved it right up there. I'm going to divide by the -2, and I get x equals -3. There are my 3 answers. I would not write this as a ordered pair. I would not write this as an ordered pair because there are 3 separate answers, x, y, and of course z. Now, I really hope you came to class because in class, I'm going to show you how to use the calculator to do this. We set up what is called a matrix. I'm going to leave you the keystrokes here so that you can see them. I don't want to go over it because I do not have the graphing calculator here for the video. So hopefully I can record that in class and add that as a supplemental video. But honestly, there's 2 different ways that you can use what is called a matrix. This is a matrix right here to help you solve these elimination problems. So hope to see you in class.